productivity, and multi-productivity. Productivity is an average measure of the efficiency of production. It can be expressed as the ratio of output to inputs used in the production process, output per unit of input. When all outputs and inputs are included in the productivity measure, it called total productivity.
Outputs and inputs are defined in the total productivity measure as their economic values. The values of outputs minus the value of inputs is a measure of the income generated in a production process. It is a measure of total efficiency of productivity process and as such the objective to be maximized in production process.
Example of a productivity. A company that processes fruits and vegetables is able to produce 400 cases of canned peaches in 1/2 hour with 4 workers. What is labor productivity? Labor productivity is what we need to calculate. So this is the partial productivity. And in the definition of productivity, it's defined as output divided by labor inputs. Now, the output is given here at the 400 cases of canned peaches produced. We only need to figure out what is the labor input. So, for the labor, some of people may think that we have 4 workers. 400 divided by 4 and get 100. Now, if the calculation you use, then you miss a very important factor, which is how many hours a worker has spent to produce the output. So this factor will make the calculation inaccurate if we don't consider in the calculation. So generally speaking, when we talk about labor input, we always use what we call labor hours as the matter which is that how many hours labor has spent on the production. So for this problem, we have 4 workers and they work 1/2 hour. So the total labor input or labor hour is 0.5 times 4 is equals to 2 labor hours. And 400 divided by 2 is equal to 200 cases per labor hour.
Joanna is currently working a total of 12 hours per day to produce $240. She thinks that by changing the paint used for the facial features and fingernails that she can increase her rate to $360 per day. Total material cost for each doll is approximately 3.50 pesos. She has to invest 20 pesos in the necessary supplies, expendables per day. Energy costs are assumed to be only 4 pesos per day, and she thinks she will be making 10 pesos per hour for her time. Viewing this from a total multi-factor productivity perspective, what is her productivity at present and will the new print? When solving multi-factor productivity of current and new print, they includes the labor, material, supplies, and of course the energy. And we must find the output. In current, the labor must have 12 hours to produce the dolls, multiply by the 10 per hour that she thinks she will be making. That will be equal to 120. In material, the total material cost for each doll, which is 3.50 pesos, multiplied by the total of dolls that produce equivalent to 240 pesos. That will be equal to $840. In supplies, it is already given on the problem, which is 20 pesos necessary supplies per day. And energy have a 4 pesos assumed per day. After the total, the labor, material, supplies, and energy, which is 120, 840, 24 pesos is equal to 984 pesos. To find the output, the total dolls produced divided by all costs, which is 240 divided by 984 is equal to 24 pesos. That will be the productivity. When solving with new print in labor, like in Karen must have 12 hours to multiply by 10 per hour that she thinks she will be making, that is equal to 120. In materials, the total material cost for each doll, which is 3.50 pesos, multiplied by the total of dolls that she can increase her rate to 360 dolls per day. That will be equal to 1,260 dolls. Supplies is equal to 20 pesos and energy is equal to 4 pesos assumed per day. And total all costs, the labor, material, supplies, energy, which is 120, 1,260, 20 pesos, 4 pesos is equal to 1,404 pesos. And then to know the output of new print, we must divide the increased rate that she can produce and the total of cost, which is 360 divided by 1,404 is equal to 26 pesos.
What is a project management? Project management is a discipline of planning, organizing, motivating, and controlling resources to achieve goals. The primary challenge of a project management is to achieve all of the project goals. Nowadays, project management is regarded as a very high priority as all the companies or organizations, whether small or large, are at one time or another involved in implementing new undertaking innovation and change.
What is a project? Project is a temporary, unique, and progressive attempt or endeavor made to produce some kind of tangible or intangible result. Project, it is usually includes a series of interrelated tasks that are planned for execution over a fixed period of time. It is a temporary in that it has a beginning and end in time. Project characteristics. Single unit, difficult production planning and inventory control, may involve considerable cost, high labor skills. Single unit. Projects may involve a single unit of one organization or may cross organizational boundaries. Difficult production planning and inventory control. In project management, production planning utilizes the resource allocation of activities of employees, materials, and production capacity in order to serve different customers. So it is hard task, while the inventory control, it is activity of checking a shop stock. Why is it hard or difficult? It's a never-ending battle. It's complex and it takes time. Inventory levels are constantly fluctuating and consumer demands keep changing. May involve considerable cost. It costs a considerable amount. They took a considerable length of time to decide. High labor skills. Generally characterizes by high education or expertise levels and high wages. Management of large projects. Planning, goal setting, project definition, team organization. Goal setting, you have a desired goal. Project definition, you know all about your project. Team organization, it has a teamwork. Scheduling, relating people, money, and supplies. Deciding if they better off keeping people on the payroll during slowdowns. And they also decide who is their good suppliers. Controlling, monitor resources, cost, quality, and budgets. You monitor your business every period of time. You minimize the cost or budgets. You have an alternative plan if the first plan did not succeed. Key decisions in project management. Deciding which project to implement, selecting the project manager, selecting the project team, planning and designing the project, managing and controlling project resources, deciding if and when a project should be terminated. Traits of project managers. Traits of project managers. Command authority naturally. In other words, they don't need borrowed power to enlist the help of others. They just know how to do it. They are optimistic leaders. Second one, possess quick sifting abilities, knowing what to note and what to ignore. The latter is important since there's almost always too much data. Ignoring writings is better than trying to master extraneous data. Set, observe, and re-evaluate project priorities frequently. They focus and prioritize by handling fewer emails, attending fewer meetings, and generally limiting their data input. Ask good questions and listens to stakeholders. They care about communication and opinions of the parties involved. Do not use information as a weapon or a means of control. They communicate clearly, completely, and concisely. Adhere to predictable communication schedules, recognizing that it's the only deliverable early in a project cycle. All this takes place after very thorough pre-execution planning to eliminate as many variables as possible. Possess domain expertise in project management as applied to a particular field. They have a deep familiarity with one or multiple fields that gives them a natural authority and solid strategic insight. Exercise independent and fair consensus building skills when conflict arises. They embrace only as much as is absolutely necessary, neither avoiding nor seeking grounds for control of a particular project segment. Cultivate and rely on extensive informal networks inside and outside the firm to solve problems that arise. They identify any critical issues that threaten projects and handle them resolutely. Number 10, lastly, look forward to going to work. They believe that project management is an exciting challenge that's critical to success. Project organization defines the human infrastructure of the project. The task is designed to define the project organization chart, the roles, and the relationship of the project team. Here are the examples of a project organization. Project planning. The project is planned to an appropriate level of detail. The main purpose is to plan time, costs, and resources adequately to estimate the work needed and to be effectively manage risk during project execution. Project scheduling is the tool that communicates what work needs to be performed, which resources of the organization will perform the work, and the time frames in which that work needs to be performed. Project scheduling. Assign people, schedule resources, sequence activities. Project controlling is that element of a project that keeps it on track, on time, and within budget. Data gathering, management, and analytical processes used to predict, understand, and constructively influence the time and cost outcomes of a project or a program.
Why do we need to study different techniques in operations management? Those techniques like Gantt chart, PERT, and CPM are created for project manager and project scheduler. We all know that one of the main responsibility of a project manager is to make plan and make a schedule to finish specific activity efficiently and effectively.
PERT and CPM. PERT is the acronym for Project Evaluation and Review Technique, while CPM is the acronym for Critical Path Method. So what is PERT? PERT is a statistical tool used in project management which was designed to analyze and represents the tasks involved in completing a given project. PERT is a project management technique that shows the time taken by each component of a project and the total time required for its completion. PERT was developed by the U.S. Navy for the planning and control of the Polaris missile program, and the emphasis
was on completing the program in the shortest possible time.
CPM, or the Critical Path Method, is one of several related techniques for doing project planning. CPM is for projects that are made up of a number of individual activities. CPM is a step-by-step project management technique for process planning that defines critical and non-critical tasks with the goal of preventing time frame problems and process. CPM was developed by DuPont and the emphasis was on the trade-off between the cost of the project and its overall completion time. Critical Path Method can help you figure out how long your complex project will take to complete, or how will you manage a complex project efficiently and effectively, and which activities are critical, or what activities you have to be done on time. The 6 steps common to PERT and CPM. First, define the project and all of its significant activities or tasks. Second, develop relationships among the activities or decide which the activities must precede and which must follow. The third, draw the network connecting all of the activities. The fourth one is assign time and cost estimates to each activity. The fifth one, compute the longest time path through the network, or what we call the critical path. And then last but not the least, use the network to help plan, schedule, monitor, and control the project. PERT or CPM are networks generated. It provides valuable project documentation and graphically point out who is responsible for various project activities. It is also applicable to a wide variety of projects and industries. It is useful in monitoring not only schedule but cost as well. Limitations of PERT and CPM. It assumes clearly defined, independent, and stable activities. It do not clearly indicate details regarding stability of project. Second, specified precedence relationships or the relationships between happenings before. Subjective time estimates and the overemphasis on critical path. Gantt chart is a horizontal bar chart developed as a production control tool in 1917 by Henry L. Gantt, an American engineer and social scientist. Gantt chart is used in project management and provides a graphical illustration of a schedule that helps to plan, coordinate, and track specific tasks in a project. Gantt charts are quite commonly used because they provide an easily graphical representation of when activities may take place, but it does not clearly indicate details regarding the process of activities.
My topic is all about human production design. What is production design? As the customer wanted it, as a marketer interpreted it, as a professional made it, as a engineering design.
What are the components of product? Brand name. Name given by the maker to a product or range of products, especially a trademark. A familiar or widely known name. 2. Product area. Product area components allow you to introduce additional line items to your products. 3. Packaging. Wrapping material around a consumer item that deserves to contain, identify, describe, protect, display, promote, and otherwise make the product marketable and keep it clean. And always remember, packaging is more than just your product face-to-face. Physical. Outcome of human efforts to meet the wants and needs of people. Features. A function of an item which is capable of gratifying a particular consumer need. It It is hence seen as a benefit of owning the item. Quality level. It's the quality that your product will become. Stop ko na ngayon. Production strategy opinion. Production depreciation, low cost, rapid response. Production depreciation. The first strategy you have to differentiate your product to your competitive. Low cost is the most one product strategy because the customer become more interesting but your product still have quality. Rapid response. Simple facts strongly incentivize you to prioritize the speed, effectiveness, and quality of your response to reduce the generation of new product opportunities, economic change, sociological and democratic change, technological change, political legal change, economic change. It's quickly change in our generation or what's the latest, what is the 2. Sociological and democratic change. Sociological, oriented and directed towards social needs and problems. 2. Demographic change. You must know the changes of demographic that occur in large group or people over a period of time. Technology. Product development stages. Idea generation, assessment of firm's ability to carry out customer requirements, functional specifications, product specifications, design review, test market, introduction to market, evaluation. Idea generation, provide basis for entry into market, source of ideas, market needs, engineering operation, technology, competitors, inventions, employees, and follows from marketing strategy. Issues for product development. Robust design, modular design, computer-aided design, concurrent engineering, environmentally friendly design. Robust design, strongly formed or built, successful or impressive, and not likely to fail or weaken. Modular design, having parts that can be connected or combined in the different ways. Time-based competition. Product life cycles are becoming shorter. Faster developers or new products gain and slower developers and obtain a competitive advantage. Service design. Be especially discreet when talking with customers through the microphone. Provide written instruction for customer who must fill out forms you provide. Mark lines to be completed or attach a note with instructions. Establish eye contact with the customer if the distance allows it. Always say please and thank you. If the transaction required that the customer park the car and come into the lobby, apologize for the inconvenience.
What is statistical process control? It is applied to control and monitor a process. The objective of process control system is to provide a statistical signal when assignable variation of causes are present.
Statistical process control, a technique that measures performance of a process, which ensures that processes are meeting the standards and are performing according to its intended design. SPC is applied in order to monitor and control a process. Monitoring and controlling the process ensures that it operates at its full potential. At its full potential, the process can make as much conforming product as possible with a minimum of waste. SPC can be applied to any process where the conforming product output can be measured. Key tools used in SPC include control charts, a focus on a continuous improvement, and the design of experiments. An example of a process where SPC is applied is manufacturing lines. SPC limitations. SPC is applied to reduce or eliminate process waste. This, in turn, eliminates the need for the process steps of post-manufacture inspection. The success of SPC relies not only on the skill with which it is applied, but also on how suitable or amenable the process is to SPC. In some cases, it may be difficult to judge when the application of SPC is appropriate. Statistical Process Control, or SPC, has two variations, which is the natural variations and the special causes variation. Natural variations, also called common causes, expected amount of variation. Output measures follow a probability distribution. If the distribution of outputs falls within acceptable limits, the process is said to be in control. In short, common causes or natural variation is a type of cause which produces a stable and repeatable distribution over time. Assignable variation, also called special causes of variation. Generally, this is some change in the process. Correctable problems, machine wear, unskilled workers, poor materials, specific causes. In short, it refers to any factor causing variation that affects only some of the process output. They are often intermittent and unpredictable. Samples. To measure the process, we take samples and analyze the sample statistics following these steps. Letter A. Samples of the product, say 5 boxes of cereal taken off the filing machine line, vary from each other in weight. You can see the frequency and the weight. Each of these represents one sample of 5 boxes of cereal. If you get or remove 5 boxes of cereals, they make changes in their weight. Letter B. After enough samples are taken from a stable process, they form a pattern called a distribution, which means after they are collected and stable, they will be distributed. The solid line represents the distribution. Letter C. There are many types of distributions, including the normal bell-shaped distribution, but distribution do differ in terms of central tendency or the mean, standard deviation or variance, and shape. Letter D. If only natural causes of variation are present, the output of a process forms a distribution that is stable over time and predictable. We all know that natural causes is type of a cause that produce stable and repeatable distribution over time. Letter E. If assignable causes are present, the process outputs is not stable over time, is not predictable. Steps for effective control. Set standards. To establish control over a process, you must first decide what standards you will use for reference points. Standards define the goals of your efforts. They express recruiting targets, quality controls, budget goals, or flight schedules. Number 2, define performance monitoring procedures. The next step in achieving control is deciding how to measure performance, what information to require, and how to obtain it. Performance data may be gathered from personal observation, written and oral reports, inspections, and automatic data processing products. Number 3, evaluate performance against standards. Compare performance data to establish standards. The results of this comparison indicate where you are in relation to your goals. If everything is on track, take a bow. If things are beginning to stray off course or come unrevealed, decide whether or not to take correction action. Number 4, and the last one. Initiative corrective action. If performance standards are not being met, you should start corrective action. Example, your monitoring system, is it accurate? Do performance standards accurately reflect mission requirements? Are your standards too high or too low? If your monitoring methods and standards are adequate, examine the production methods and workforce factors. Types of statistical quality control. Statistical quality control, the application of statistical techniques to measure and evaluate the quality of a product, service, or process. The process control. It is the application of statistical techniques to determine whether a process is functioning as desired. Acceptance sampling. The application of statistical techniques to determine whether a population of items should be accepted or rejected based on expectation of a sample of those items. Variable charge. It is the characteristics that are measured on a continuous scale. Attribute charge. It is the characteristics that are measured as either acceptable or not acceptable, thus have only discrete binary or integer values. Control charts. It is constructed from historical data. The purpose of control charts is to help distinguish between natural variation and variations due to assignable causes. A control chart is a graph. It shows whether a sample of data falls within the common or normal range of variation. A control chart has upper and lower control limits that separate common from assignable causes of variation. The common range of variation is defined by the use of assignable causes. This is a formula for computing the mean charts or X charts. Upper control limit or UCL is equal to X bar plus Z theta sub X bar. Lower control limit or LCL is equal to X bar minus Z theta sub X bar. X bar is equal to mean of the sample, means or a target value set for the process. Z is equal to the number of formal standard deviation. Theta sub X bar is equal to standard deviation of the sample means. Theta sub X is equal to theta divided by square root of n. Theta is equal to process standard deviation. N is equal to the number of observation per sample. For X charts, when we don't know the theta, upper control limit or the UCL is equal to X bar plus A sub R bar, and lower control limit or the LCL is equal to X bar minus A sub 2 R bar. R bar is equal to average range of the samples. A sub 2 is equal to control chart factor found in table S6.1. Sample problem. Energy drink bottles are labeled net weight 16 ounces and overall process average of 16.01 ounces has been found by taking several batches of samples in which each sample contained 5 bottles. The average range of the process is 0.25 ounce. Determine the upper and lower control limits in this process.
Today, I will discuss the second type of control chart, the R chart, or also called range chart, and the two types of control chart for attribute. The P chart, also called the percentage chart, and the C chart or count chart. R
chart, a type of control chart used to monitor variables data when samples are collected at regular interval from business or industrial process.
Range chart. This is one example of getting upper and lower control limit range. UCLR, or the upper control limit, and the LCLR, or the lower control limit. R is average range of the sample, and the D3 and D4 is the control chart factor from table S6.1. The D4 is for upper control limit, and the D3 is for the lower control limit. The number 5 step in using control chart. Calculate the upper and lower control limit using the following formula. UCL is equals to CL, or the certain line, plus 3 times S, or the standard deviation. And the LCL is equals to certain line minus the 3 times the standard deviation. Step to follow when using control chart. 1. Check to see that your data meet the following criteria. Data should usually be normally distributed, revolving around the mean, or average. 2. Find the mean of each subgroup. To find the mean, add all measurement in the subgroup and divide by the number of measurement in the subgroup. 3. Find the mean of all the mean from the previous step. This will give you the overall mean of all data points. The overall mean will be the certain line in the graph. The number 4 is calculate the standard deviation of the data point. The number 5 step in using control chart. Calculate the upper and lower control limit using the following formula. UCL is equals to CL, or the certain line, plus 3 times S, or the standard deviation. And the LCL is equals to certain line minus the 3 times the standard deviation. 6 to 9 step to follow when using control chart. 6 refers to step 7 through step 10. 7. Draw a line at each deviation. 8. Graph the X-bar control chart by graphing the subgroup means y-axis versus the measurement of y-axis. 9. Evaluate the graph to see if the process is out of control. The last step to follow when using control chart. State whether the system is in control or out of control. Control chart for attribute. Attributes are typically classified as defective or non-defective. Measuring the defective involves counting them. Type of control chart for attribute. The P chart is measure the proportion of defective in the sample. The C chart control the number of defects. P chart, a type of control chart used to monitor the proportion of non-conforming unit in a sample, while the sample proportion not conforming is defined as the ratio of the number of non-conforming unit to the sample size. The P-chart only accommodates pass and fail type inspection as determined by one or more go-no-go tests, effectively applying the specification to the data before they are plotted on the chart. Other type of control chart display the magnitude of the quality characteristic under study, making of troubleshooting possible directly from those charts. Here is the formula used to calculate a P-chart. P-chart is used to evaluate the process stability when counting the number or fraction defective. P-chart is used when the sample size is varies Example includes the number of defective product, meals in a restaurant, incorrect prescription, bills, invoice, paycheck, etc. C chart or the count chart. C chart or count chart is an attribute control chart that displays how the number of defects or nonconformities for a process or system is changing over time. The number of defects is collected for the area of opportunity in each subgroup. The area of opportunity can either a group of unit or just one individual unit on which defect count are performed. The C chart is an indicator of an consistency and predictability of the level of defect in the process. When constructing a C chart, it is important that the area of opportunity for a defect be constant from subgroup to subgroup. Since the chart shows the total number of defects, when the number of items tested within a subgroup changes, then a U chart should be since in the show the number of defects per unit rather than the total defect. Acceptance sampling, a form of quality testing used for incoming material or finished good, involves taking random sample of lots or batches of finished product and measuring them against predetermined standards. The procedure of acceptance sampling. First, take one or more sample at random from a lot or shipment of items. Second, inspect each of the item in the sample. Third, decide whether to reject the whole lot based on the inspected result. 3. Managerial consideration of control chart. First, at what point in the process should control chart be used? Second, what size sample to take? Third, what type of control chart to use?